Fine. So yesterday I think we started with the collection framework. Fine. We have seen the hierarchy of the various kinds of data structures, fine, for which we have got interfaces. It's a hierarchy of interfaces. We have the collection. Fine. Under collection we have got set, list, queue. Okay. Fine. Okay. For fine. Another thing what we have seen is we have seen the operations available on collection. What are the methods available in the collection interface? We have seen all the abstract methods. Okay. There is a method related to the iteration. Fine. It returns an iterator. And we have a method called Iterator to return an iterator, and that method comes from iterable interface. Fine. We also saw a method called for each, and this method comes from iterable. The default method is for each, which comes from iterable. So iterable has for each. Okay. Fine. A few other methods. Fine. Let's see. So now a method from iterable. If I look at methods from iterable, fine. We have seen the abstract methods, right? With the abstract methods, we are fine. Okay. Fine. Quick review. Collection. What are the basic operations? Add, remove, which one? Contains, to check whether it is basic operations, right? Yeah. Whether an object is contained in this or not, yeah. Contains, then is empty, fine. Then you can know the size, you can clear. And these are the basic operations on a collection. Okay, then fine. Array related methods. There are two methods for array. To array. Fine. To array without parameter returns object array. Fine. To array with a parameter, where the parameter is an array. Array of the type which you want. Fine. You want it to return a array of a particular type, so that's the type of array which you should be passing. Fine. It would update the array, fine, with the elements from the collection, but anyway it will always return an array whose size matches the size of the collection. Fine. Same size as the size of the collection, so that array would always be returned. Okay, so two array methods. Then method for iteration. Fine, that's a iterator method which returns an iterator. Okay, fine. So then we had those bulk operations. What are the bulk operations? Yeah, 4 of them. One is add all, remove all, retain all, and then the contains all. Fine. Methods of iterator. Iterator. The iterator has methods called next, has next, and next. Has next and next. Those are the majorly used ones. Also a method called remove. Okay, fine. Iterable. Let's fine. Iterable has the default method called. Okay, now coming to the default method. So iterable has a default method called. What was the default method? So this method comes from iterable. Okay, it's there in collection, but it comes from iterable. Okay, so the first default method which we had seen, and we have the fine returns void Name of the method is for each. And what's a parameter? It's a consumer of E. Fine. The action to be taken. Okay. And this method is inherited from iterable. Fine. Collection extends from iterable. Fine. From where the iterator method is also there, but the default method which comes here. So this is Java 8 onwards, okay? And this method is Java 8 onwards. It's a default method. Default methods are from Java 8. Okay. Next. Yeah. One was for each. This is default from iterable. Another method which comes from iterable. Iterable has abstract method to return iterator. Okay. It has a default method to return splitterator of E. Method name is splitterator. Okay. Maybe we may not be using this. Fine, you may not be required to use this much. Okay. But just understand what is a splitterator. Okay. The idea behind a splitterator. We understand iterator. Fine. Say you may have a collection, right? Having a number of objects in it, and there are number of objects. Okay. When we create a iterator, fine. We have the iterator method as well, right? Just like splitterator. If we have an iterator, yeah, it's one object which is keeping a tab on all the elements which are there, right? You can sequentially, one by one, you can go through all the elements, and it allows you to go through all the elements in the underlying collection. Okay. Now, what is a splitterator? A splitterator is a one. Fine. So, if you get a splitterator for a collection, and on a collection you are asking for a splitterator, fine. It's just like the iterator. Fine. That means it also has a capability to go through elements of the underlying collection one by one. Okay. But one thing what is available here is it has a method called try split. So it's an iterator which can be split. Right? So on this splitterator, if it's a splitterator, right? On a splitterator, if you call a method called try split, it would return another splitterator. And when it returns another splitterator, what it has done? It has done the splitting of elements. Okay, half the elements will be can be sequentially gone through by this, and half the other elements can be gone through by this. So it splits the work. Splits the. It's like I want to distribute the elements and have them in separate splitterator. Okay, fine. So one can go through this sequentially, and this is also going on sequentially. So two things. There are two objects by which you can cover all the elements in the collection, and they are distributed into two. And if we got multi-threading, and they can be processed simultaneously. Fine. This sequence is being processed, this sequence is also being processed. So that's what is possible. And if one decides, he can further split this also again and split this also again. If you got more cores, you can keep on splitting it. Okay, so the idea splitter is just a iterator only. Fine. Okay, fine. Methods point of view. Fine. Let's have a look at the methods in the API. Fine. Let's see what is there in splitter. Fine. Okay. Fine. So if you look at splitter, okay, it's an interface. Fine. Okay, and the methods here. Fine. We may first have a look at just the abstract methods. Okay, splitter can have characteristics. That's fine. One thing is there is an estimate of the size. How many elements are there in the splitter? Okay. Fine. The other method, like instead of a method called next, see what do we do? After using a next, then we'll use, so next, first we'll say has next, right? See, in order to process element from a iterator, fine, I'm comparing with iterator. In case of a iterator, what we normally do is, we'll say has next. If it has next, then we ask for the next element. Fine. And then on that element we'll do some processing. All these three combined into one method. It says try advance. What is try advance? Has next is the check. If it is false, return immediately with a false. If it is true, fine, use the next method, get the next element and do this processing. Consumer is there. What is the processing you want to do on the element? Try advance using this processing step. So apply the processing in one step itself. Fine. Compare this with what you were doing. Fine. And the other thing is, okay, so this is one try advance which is fine, which is there. Try split is one which I had explained, right? So see, there will be a point, you can't split further. If your elements which are covered by this, if it's only one element, you can't split it, right? Fine. So it's always a try split. So fine, try split will just try to, if this splitter can be partitioned, right? Returns a splitter covering elements that will upon return from this method not be covered by this splitter. Okay, then it won't be covered. So it returns a splitter which is nothing but all those elements which will not be covered by this iterator, splitter now onwards, and they'll be covered by the other one. Okay, if you look at the default methods now, so default method which uses try advance is something like this. There is this method called for each remaining. So process everything, and that was one. Try advance was only one, but this is for each remaining. Fine. In the characteristics, it could be a sorted one. So if it's a sorted kind of a, fine, underlying collection is a sorted one. Okay, what is the comparator which is used for sorting that? If it's available, that would be given. Get comparator. If the exact size is known, fine, get the exact size, and you have characteristics basically. Okay. Fine. You have got characteristics, and let me just check where the characteristics are going to be. What are the characteristics? Return a set of character and okay. So the characteristics, the result is represented by odd values from ordered, distinct, sorted, and sized. Non-null, immutable, concurrent, and subsized. Okay, these are nothing but constants here. One second. Okay, fine. So there are integer constants to represent different kind of characteristics of the splitrator. It can be, so see, if it's a set, that's a distinct characteristic. Fine, set is a distinct characteristic. A list would be a ordered characteristic. Fine, fine. Normally they are sized. Fine, splitrator we are thinking it's always for a collection, but it's not that it's only for a collection. Fine, splitrator is for anything which is iterable. Fine, iterable things can be infinite also. Okay, so whether it is sized or not. Fine, immutable. Fine, immutable means you can't remove, replace elements in the underlying collection. Fine, distinct is fine. Concurrent. Okay. Fine. So whether concurrent access can be done or not. Fine. Whether concurrent access on the concurrent operation on the underlying collection can be done. So these are the characteristics we have. Sized, it's a sorted, it's a subsized. And after a tri-split, it is subsized also. Fine. So if the splitrator says it is subsized, that means you can see, understand it's not covering the entire thing. It's only a partial one. Fine. See one thing, splitrator we may not directly be using. This is something which Stream API makes use of. And there's a whole Stream API. It's making use of splitrator. Okay. Fine. Okay. Okay. Another thing, if you note in the API, we have iterator of some element type E. Fine. That means yes, you can iterate over elements of type E. But same way, you also have a primitive iterator. Iterator for iterating primitive values of type int, long, or double. So there is one super interface, okay, and then this has the three sub interfaces. Primitive iterator of double, of int, or long. And int, long, double, three things. Okay, from methods point of view, I think fields will be there, methods. Fine. It's for each remaining. Okay. And that same method for each remaining, you want to have it processed. And okay. So if I look at, maybe we'll just look at the int. What it would have is, it would have a method like this. For each remaining, it's a consumer of integer or int consumer. You may have a int consumer. Okay. Next and next int instead of has next and next would return integer. Fine. We have the method called next int. Has next is anyway there. It's extending from iterator. So has next is there. When you say next, it would be integer object, not int, right? But you could be using next int. Okay. Fine. So primitive versions for iterator. Same way, there's a primitive version for splitrator. Fine. Okay. Fine. Splitrator, and then we have the. But anyway, splitrator is the method in iterable. Fine. Splitrator is the method in iterable. Fine. So if we start from collection, yes, we don't get anywhere anything like a primitive iterator or a primitive splitrator. Okay, we won't get those things. Fine. There are other places where they'll be used from. They'll be used from streams. Fine. Okay. So these two default methods anyway you will be getting in collection. Fine. So what collection gets is this. Default method for each. There's a default method called splitrator. Okay. We saw a default method as well. What was the other default method? In collection. What's the other default method? Remove if. Fine. Remove it's returning a void. Method name is remove if. Parameter is predicate. And the test. And this was one. Okay, another one. Oh, there are two more, right? Two other default methods, and they both return a stream of E. Method name is stream and parallel stream. Fine. So that's what you get in collection. Fine. And then we have the other interface called set. Fine. What is set? Collection of unique elements. Fine. And therefore a set doesn't have duplicates. Fine. Set doesn't have duplicates. It's exactly a collection. Set is exactly a collection where no duplicates are allowed. So methods point of view, what we have seen for collection is what is applicable to a set. No additional methods for set. Okay. And then, so next thing, let's look at the list. Okay, so if you look at list of E, it extends from collection. Okay, so We know the methods of collection. Now what we look at are the additional methods in list. List is ordered, has index positions. Fine, it has index positions. When you add an element, right, using the add method, it is always added at the end. Fine, it is always added at the end. So index position is whatever is the current size. Where it will be added? Whatever is the current size. Size is 0, it has 0 elements. So index position 0 is where the add would be adding. Fine. Since it's maintaining index positions, the add method has been overloaded. So add would return a void. So this is again abstract method from list. The method name is add. Fine. Recollect, add earlier was boolean. Fine. Here return type is void. Okay. And the parameter, it takes index and then the element e. At this index, insert this element. Fine, it's an insertion. Yeah.
Last में ही add होने वाला है.
Add without a index. The earlier add which you inherit. The add which you have inherited, where you don't specify index, it's always at the end. Okay, but you have the option now of using the index and saying insert here. And let's say you have got 10 elements, so their index positions are from 0 to 9, and then you could be saying add at index position 5. Okay, what will happen? Whatever was from 5 to 9, they get shifted to 6 to 10, and at 5 this element will be inserted. Okay, so it's an insertion. Okay, fine. We had one remove method earlier, which was returning boolean. Fine. E. E. This one. It's a list of transaction. Let's say it's a list of transaction, right? In that case, it is transaction. In a list of transaction, you will be adding transaction only, not anything else. And so we have the add method. Fine. We had the remove method earlier. Okay. So say we have the remove method being overloaded. Remove method return type is E here. But this is removed by index. At this index, whatever you find, remove it. And when it removes, it returns that value. That object is returned by the method. It gets removed from the list. Okay. Fine. The size would be changing, and the size would be shrinking. Fine. If there are 10 elements and you say remove from 5, so 6 to 9 will become 5 to 8. Fine, you are deleting from 5. Fine, you are saying remove from 5. Fine.
So ये सारी method abstract है ये.
Yeah.
Collection.
Collection may be in this list. What I am mentioning are abstract methods. So this is interface, and we will have class which implement these interfaces. So we have to create object of the class and use it. Okay.
Sir इधर वो shadow वाला होगा ना, shadow. ये जो
Default methods नहीं.
नहीं वो shadow वाला concept है. वो shadow करेगा.
For
Super class की method का same नाम होगा. नाम same है दोनों.
No, it's for variables. This is overriding. Methods have overriding. Variables have shadowing.
सर ये overriding कैसे होगा, मतलब type अलग-अलग नहीं है. इसमें boolean का इसमें void है.
Acha, this is overloading. This remove method is overloaded. That other earlier remove is there, but that's an object, not int. This is int. And that one is taking the object. Okay. What you have pointed out has a small thing. It's related to, suppose you have a list of integer, right? So if there is a list of integer, okay, and list containing integer objects, wrapper object. So yes, you can have a list of, you can't have list of int anyway, but if you have a list of integer, okay, L1, fine, and then someone tries L1 dot remove and gives a 3, which will be applicable. It won't do a boxing conversion here, okay, fine, it won't do the boxing conversion and do the, no, it's not that boxing conversion happening here, it's using the index here, okay, and this is going to use index, fine. But if you pass the integer object, okay, I have integer object a equals 3, and then someone passes a here, yeah, which will be used, the remove, which is returning void, okay, and that's an overload. Because with int integer we expect a boxing unboxing for integer type. Fine. Okay, so we have add, fine, and then we have the remove. So this is operation. See, what we are adding are methods which are based on indexes now. They all involve indexes. Add at an index, remove from an index which was not available because it wasn't ordered. This is ordered. Okay, now you'll have indexes being used. Yeah, what else? Add, remove, what else? Size anyway, size is the same. Yeah, those are the methods anyway inherited. Right? They are inherited from, so they are still there. The other remove is still there.
Okay.
Yes, it's fine. You can get from an index position. Wait a minute, इसका.
सर ये जो ऐड और रिमूव मेथड है वो ओवरलोडेड. तो सर जो कलेक्शन होगा उसकी ऐड और रिमूव मेथड भी होंगी इसमें.
हाँ, they are still there. Yes.
तो सर अभी हम क्लास बनाएंगे.
हाँ.
जो इसको इम्प्लीमेंट करता होगा.
It will have both the methods.
तो दोनों को करना पड़ेगा.
हाँ, it has to implement. Fine. I mean, both forms, it's a overloaded method. It's a overloaded method, right? The class will have to implement all the abstract methods. So, right? If it's overloaded, yes, it has both forms of add. It has got both forms of remove. And both forms of add are there. Add with only one parameter, add with two parameters. Remove for the element type, remove for index. Fine, remove with index. Okay, fine. Then you have got the get method. Fine, so return type will be, and the method is get parameter index. See, another thing I just wanted to, why I had taken that list of integer. Okay, and when I said L1 dot remove a, in a list of integer, it's going to use a as integer. Note, it will do a unboxing. But if it was a list other than integer, anything other than integer, and if I use L1.remove, okay, on that list if I call remove and pass a integer object, unboxing would take place. Let's say instead of list of integer, this was list of account, and if you pass a, where a is a integer, it would be considered as int. Unboxing would be done to int, and then it will be used as if you are giving index. This is a list containing account objects. Remove has been invoked by using integer object. Then it is obvious it is to be converted to a int. Okay, but when it is a list of integer, and then it depends what you are doing. And it's not the one with the index, right? Okay. Okay, fine. So we have the get method. Fine. See, now you have got order, and so you can ask for element from any index position. Fine. You can ask for an element from an index position. Fine. Okay. Fetching. It's not removing. It's not updating the list. Okay. It's giving you the object from the list. Fine. Remove was also giving you object from the list, but it was getting removed from the list. This also gives you object from an index position, but it stays there. It stays in the list. Fine, that's the difference. Fine. You can get and you can replace. So there's a method called set, where you specify index and the element. Returns E. What does it return? When I say set, at index 5, set this. What will happen?
It will remove existing.
Okay, and put the new one. The existing is the one which it is returning. It's returning the old element at this index and sets a new one there. Okay, at this index, set this one. Okay, what is returned is what was earlier there. The method returns the old value at this index. Okay, fine. There's a get, there is a set. Okay, fine. Another one is for locating elements. Locating elements in the list. You can locate element in the list by using a method called, it's returning int. What is the index position? Okay, so return type is int now. Index position, so I'll say index of. So what is the index of? And I'm giving you an object. So locate this object and tell me what is its index position. Okay, tell me the index position of the object. Fine. We have the method to return a list of E. Fine. From a list, I'm again taking the list of the same type. Okay. Name of the method is sublist. Sorry, L is capital, I think. Yeah. Sublist. Fine. returns a list. What you specify are the index positions. Int the start index, another int for the end index. Fine. Now the end index is not included, okay? Starting from this up to but not including the end. Okay. So if I say L1 dot sublist, three comma 9, I will get 6 elements. Okay, the elements from 3, 4, 5, 6, 7 and 8. Fine, 9 is not included. And index positions from 3 to 8, that's what I get. So a new list, fine, the 0th element there will be what was 3 in this element, in this list. Okay, so you can have a sub list. Okay, like you have index of, see, a list has no restriction that, oh, you can always have duplicates also here. Okay, when there can be duplicates. So one is the method called index of, and another is a method which is again looking at locating an element. So it's also returning int. Name of the method is last index of. Fine, and you give the object. So what this method does is it starts searching for the object from the last index and goes from right to left. Fine, and the first occurrence is where it will return. This is the index where I have found it. Okay, see, index of and last index of, they are nothing but search operations. Fine, search operation based on equals method. Okay, this will be by equals. Fine, start comparing. If equals returns true, that's the index I have. Fine, but first one goes from left to right, last index of is from right to left. We have the iterator inherited, fine, but then there's another type of iterator which is available for the list. Since list is ordered, has indexes, and the underlying thing has indexes. In earlier case there were no indexes. Collection, no indexes, but this one has indexes, right? And therefore we have another kind of a iterator called the list iterator. Name of the method is list iterator. Okay. This interface list iterator extends from the iterator, and list iterator is extending from iterator. Fine, we had 3 methods in iterator, fine, and there are 9 methods in list iterator, including those 3. Okay. Let's see, they are quite simple. So we look at methods of list iterator first, and then we'll continue with the list. Okay, so what is there in list iterator? Okay, fine. So we have the method. What were the methods we had? We had a method called hasNext, right? Returns boolean was one. Right. Same way, we also have a method to return boolean. Name of the method is has previous. Has previous. You can move in both directions now. See, iterator was one way. List iterator, fine, you can go back also, fine, iterate backwards. So there is has previous. So initially, fine, initially as soon as you take a list, from a list if you ask for a list iterator and if you say has previous, that should be false. Fine, you should have gone further, you should have used next to go further, and then you can say, okay, is there a previous? Fine, initially has previous should be false, whatever the size may be. Okay. Fine, we had the method to return e, the method was next. You can guess the method here. We have the method called, okay, and then we have a method to return the index position of the element which you will get if you use the next method. So we have the method called next index, returns int. What is the index in the underlying list of the element which I get if I use next? Initially next index is 0, you have not used the next method yet. So if you are going to use next, you are going to get the element from 0. That's the next index. Okay. Same way, what's the method here? Previous index. Fine. So if I am going to use previous, see your what's your positions between previous and next? What is your position? It's between the previous and next. Whatever is your position, if you say next, you will get from next index. If you say previous, you will get from previous index. See, whenever you are changing the direction, suppose you have said next for 5 times, and now if you say previous, you will get the same element as you had got with the next. So last time what you got with next is what is becoming previous now. Fine. If I say next first time, I will get 0. If I say next again, I will get 1. If I next again, I will get 2. Now if I say previous, I will get 2. Fine, because next would have given me 3. So difference between next and previous is only 1. Fine. And this
करंट इंडेक्स हमारी 2 हुई ना,
कहाँ से 2 है? Current index, okay, if you are saying what you have already taken, what you had taken last time, yes, then
करंट इंडेक्स 1
okay, you can think of it as current index, the 2 here, ठीक है. Okay, then we have the other three methods. Oh, there was that one more method was there. What was that method? I said total 9 methods in list iterator. 6 are simple and 3 more because we have got 3 kinds of updates. One is remove, returns void. This was there, right? This is there in iterator also. What will it remove now? Current. So whatever you have obtained last, it may have been using next or may have been using previous. What you have got last time using either next or previous, that's the element to be removed. Fine, you might have said previous and moved this side. Okay, you got previous, so that's the element which is going. Okay, there are 2 more methods. There's a method called add, which takes element A as a parameter. Return type is void, and there's also a method for set element, and return type is void. Where does it add? Okay, you have index position 0, index position 1, index position 2, index position 3, index position 4, index position 5, index position 6. Okay, there are 7 elements, let's say. Fine, you moved forward. This is 0, 1, 2, 3. Fine, you have taken next here, so that means your next would now be giving you this one, and your previous would be giving you this one, right? So when I say add, where does it add? It's between these two. Okay, and what's your position? What's your position?
4.
This is 0, this is 1, this is 2, this is 3. Okay, this is 3. What you have added has become 4. Fine. Now after adding, it will be next to it. It will be next to it, but remember, it all depends on the direction. If you were moving in this direction, then it's on the other side. How did you come to the current position? Using previous or using next? If you have come to this position using previous, it's going to be prior to that. Right? If you are coming from this direction and inserting, right, then it will be here.
सर अगर हम इंडेक्स 3 पे और नेक्स्ट इंडेक्स करते हैं 4 आएगा,
because the previous operation was a next. हाँ, next index 4 पे आएगा, 3 पे नहीं. We are never at 3 or 4. My earlier element was from 3. That's what you are saying. But how did you get that? Using previous or using next? You got 3, but how was it? Because of previous or because of next? How did you get it? It depends on that. If you have got it using previous, that means your direction is right to left. And so direction matters.
तो अगर लेफ्ट टू राइट है
हाँ,
तो उसमें नेक्स्ट करेंगे तो 4 आएगा,
हाँ,
और प्रीवियस करेंगे तो 3 आएगा.
हाँ, your current index, yes, बराबर है. Fine, same way. What is set? What it is going to replace? Set. And
प्रीवियस करें तो
okay, fine. Just look at an editor just look at an editor. You are in insert mode. Cursor कहाँ पे है? If you type, where does it gain? And this is because it is from left to right. If it is in replace mode, what does it replace and where? What's its position? It puts and is next to it. Fine. Okay. If we had an editor which was right to left, fine. Maybe there are languages, fine, where you will have to move right to left. Okay, and there, yeah, what should happen? We may not have used it, right to left editors, but yes, there are texts which go right to left. So just think from that point of view, and you should get your answers. Fine. So 9 methods of list iterator. So you can get a list iterator from a list. Okay. Okay. Fine. So let's continue with more methods of list. A few additional methods. These are all additional methods. Fine. What is addition? In addition of the methods of collection. Okay. So additional method for list. Yeah, we got sublist already. We got list iterator, get set, index of, last index of, all those things. Okay, now we can go for a bulk operation. Okay, so we have this method with bulk operation. Return type is void. Name of the method is add all. Parameter is index. Fine. And second parameter is a collection of question mark extends. So you can add another collection here. Okay. List is also a collection. Okay. Fine. List is also a collection. So elements from that collection will not, if I just use the earlier add all method which is without the index, it's adding at the end. Elements from the collection are added at the end. Here it's a insertion. Insert from this index onwards, elements from the collection. Fine. Inserting elements from a collection into the list. And so mainly here we have all methods which are nothing but they are related to indexes. Additional methods are just for indexes. Okay. There are a few default methods, additional default methods. So we have a default method now. There's a method called sort. Sorry, return type. Returns void. Name of the method is sort. And a default method sort, and I think sort with a comparator should be there. Let's just check it here in the API. And the sort takes a comparator. there's a sort which takes comparator. Okay, so it's question mark super. Fine, that's your comparator. So you can give a comparator based on which sorting can be done on the list. Fine, since this has indexes, right? Okay, this can be sorted. Other method is, other default method returns void. Name of the method was replace all. Parameter is a unary operator of E, and that's a operator. What is replace all? For every element, fine, what it will be doing? Transformation. Fine. Use that function, whatever is the element at that position, fine, pass it, it will return another value, replace it. Fine. It's a list of integer. Fine. You want to replace by doubling everything. Fine. Oh, double every element in the integer. Okay. Fine. My unary operator only doubles the value, and I have a unary operator to double each value. Fine, get this last one, replace all. Fine. Okay, now for our exercise. Okay, but before we go for exercise, we should have the name of classes which implement these interfaces. Okay, fine. As far as collection is concerned, we don't have a class which is just implementing only the collection. Okay, we do have, but then they are not. They are abstract classes. There are some abstract classes which implement collection. So it's not a full implementation. Partial implementation is there. So you can create your own. So there is an abstract collection class. Okay, there is a class called abstract collection. Same way, there is a class called abstract set. There is a class called abstract list. Okay, and then they have subclasses. Which one? The abstract set has a subclass. Okay, so the implementation for set. So now we are talking about classes, not the interfaces. Okay, so the commonly used implementations for set. Okay, so for a set, so set of E, you have classes which subclass. We have classes which implement this. So there's one called abstract set of E. This is abstract class, as the name also suggests. Okay, and then the subclass which we have from here is the hash set. There's a hash set. Okay, there's a interface. Recollect, there was an interface called sorted set, which extends from set. Okay, for us the important thing would be, if it's a sorted set, then the elements, if I'm iterating over them, the iterator which I get to iterate over elements of a set, they will be in that sorted order specified by a comparator. Okay, so we have a extension of the hash set called the tree set. This is implementing sorted set. This is simple set, this is sorted set. When I say sorted set, that means in sorted order. Either the elements are comparable, or while creating the tree set you would have specified a comparator. So the constructor of tree set would require a comparator. Okay, fine. A few other things. Most of the implementations of the collection and its interfaces, they would have one constructor which takes no parameters. A default constructor would be there, but there would also be a constructor which would take another collection as a parameter. Okay, fine. I have got some set, I have elements in a set already. I am interested in creating a new implementation of list. Fine, you say new, and okay, for list, like we have abstract list. Okay, just like this, if it's a list, right, we got abstract list, which is the abstract class, and implementation subclasses are, there is one which is a very old one, it's called vector of E, and there's another one which is the more popular, very popular, is the array list of E. Okay, we got array list, and that's the most commonly used thing, okay, for list. Okay, so if I am creating an array list, maybe the construct, so I have array list where I can use another collection as a parameter. So I'll say new array list, and I have already got my elements in a set, maybe. Oh, I can use that. So while creating a new object, some collection already has those elements which I want. Okay, I can use them. Or you may use default constructor, and those are some common constructors which you will have. Okay, fine. So that's a recommended one. Okay, for list. For set, yeah, you will use hash set. For sorted set, you will use tree set. So for list, yes, we will have a vector or array list. These are common used. Okay, there's something called linked list also, I think. There's another class, linked list. Okay, anyway, so array list is the commonly used one. So now coming to the exercise part. Right? List is managing things in order, index order, just like an array, and it's using it just like an array, fine, and has better things, right? There are better methods available on list as compared to a array. Array has, yes, you fetch from index position, right? You have array indexes, and you have got, you can't, you can't just extend an array. Array has limited fixed sizes. In case of a list, you just keep on adding elements. Yeah, it will grow automatically. It doesn't have a fixed limit or any such thing. Okay, fine. So using list is more advantageous. So what we have done earlier in our exercise was managing a passbook, for which we had used two things. We had an array and next transaction index. Fine. So instead of that, we may use a list. Fine. So we should be using a list instead of array. So most of the time it's a list which is preferred over a array. Fine. Array of some element type, instead better would be to use a list of that type. Okay, fine. So let's see what changes will be required, and we'll make the changes in the account class now, and we'll see things will become easier. And the things are now going to be much easier. Okay. Yeah, so if you go for the changes, the instance variables, fine, these two instance variables, fine, they get replaced with a list of transaction. Equals, now only where we have to create an object, right, that's the time when we use a class names, and we don't, otherwise we use everything in terms of interface. Fine. So variable is of type list, but initialize with the help of a class. Right. So we are saying, oh, it's a array list, and it's a generic type. So okay, yes, you'll have to use it this way. Find list and array list, two things. And so instead of these two things, we now have a list like this. Fine. And let's see the changes now at other place. What's the change? Okay. So in the construct of transaction, what was happening? Oh, we had to write a for if a condition, right? So we don't need the if condition. Fine. All this goes, instead it would be just say add into the passbook. We don't have to check or do anything, just add into the passbook. Okay, then so this is in the construct of transaction, the change was done. Oh, we have the print passbook. Now what's the change? See, one change here would have been, yeah, okay, that's fine. Since we didn't want to go through the entire array was a fixed size, right? And therefore we had written a for like this. So instead, for each transaction T in it is, yeah, want to say this dot passbook, that's also fine. Okay, yeah, that's done. Or what's the other option? Lambda expression. But a problem with lambda expression would be, see, in this for loop I can use, it's a simple for loop and therefore I can use a local variable. If I am going for a lambda, in a lambda I can't use a local variable unless it is final. My running balance is not going to be final. It has to be changing, so it's not usable inside a lambda expression. Okay, because it's not final. Okay. So we can leave it as this, fine as it is, right? Or still, if you want, we can go for another change. Let's see, any other change needed? I think nothing, right? Nothing else changes. See? Fine, so this should still be working. Okay. And let's compile. Yeah, that compiles.
So ये passbook declare किया तब
Print passbook. Passbook we have declared as a
तब
list. Yeah.
list type था और अंदर array list क्या है वो सही है
Assignment is array list. Yeah.
सर उससे कुछ फायदा होता है मतलब सीधा array list passbook equal to new array list
Now, if you say array list, that means you have fixed it that it should only be used like a array list. You don't have an option. You're everywhere. The thing is, okay, it's according to array list. Later, someone makes a change and says, no, instead of array list, I might like to use the vector class, or I might use a different linked list class, or I want to use a different one. There are different implementations of list. Fine. So for me, the type is list. It's always better to just keep it as a interface type rather than a class type. Fine. So you can always, okay, new and whatever, I want the object of this type, which is the implementation of list. It's a list. So we are just making a statement, this is a list. Okay. Passbook is a list of transactions. I mean, this is what would always be preferred. See, you could still be working, fine, it's not that, yeah, if you write a array list, it would still be working. But we like to keep it with interfaces. So implementation, anytime if you want, yes, you can make change. Okay. And if you want, we can run the application. this is the print passbook, still working. Things, I mean, there's no change from the output point of view, but yes, what we have done is we have used a data structure. Fine. Okay. Okay. So that's a yeah. Fine. So, fine, you could also implement this. It's a small change. Fine. But you can see the change is nothing but making it simpler. And this change is making it simpler. Okay, I want to attempt something here. Want to attempt the use of for each. Fine. We can try using for. See, only the problem was with the local variable called running balance, right? That running balance is a local variable and it can't be final. There is a way out, fine, but not a good one. But I'll tell you, even if there's some local variable like this, which turns out to be final, right? Which is not final, and I'm bent on using a lambda here. I want to use it in a lambda. There is a way out. Okay, fine. Want to check that? So let's see this. One is, yes, you can't do it with a simple thing. What you might do instead is you will say, okay, you can go for a array. Instead of saying equal to 0, you could say new. The type is array of long, so you can say long. Size is 1. So now you see, as far as running balance is concerned, it is a variable which I am not going to update. I am not making any assignment to running balance. I am making assignment to running balance of 0. Running balance, right, is an array now which has one element, and this has got one element. Running balance is something which was to be updated. No, I am not updating. So you are saying running balance equal to something? That is what was happening earlier. Now it is not running balance, it's running balance of 0 equal to something. It's not the running balance being assigned a value, and therefore running balance can be final. It's effectively final because I am not assigning anything to running balance now. Okay. Yeah, transaction T into, you'll have to just say running balance of 0. Sorry. Okay. Fine. So one thing, this should work, and this should be working, and then we can switch to the lambda expression. Let me just compile. What's the problem?
First line 68. वो जरा गलती से D लिख दिया।
ये क्या है exclamation में? This no? Yeah. Okay. Fine. I want to check the result basically. Yeah, running balance works correctly, right? Okay. So now we can switch to using a for each. Yeah. Okay, I'll append it later, right? Yeah. So अच्छा, ये तो इसी में है, this dot passbook dot for each. Given a transaction T, yeah, semicolon, yeah, that's using the for each. Fine, we've written a lambda expression for each, and this part is a consumer of a transaction, right? So given a transaction T, okay, update the running balance and then a printf. Okay, so we may have to comment out. Fine. So this is just like, okay, if you still want to use a for each loop, okay, that for each method. It works. And so same results. Okay, but we have used for each.